Barry Loewer, welcome to the podcast. Thank you for coming in today.
Sure.
I'm going to start us off with an easy one. What is philosophy of science, and why should we care? Why does it matter?
Well, about the second question is I never want to tell anybody what they should care about. People have to decide themselves what they care about. But I can tell you what philosophy of science is, or what I think it is. This is human activity that has been going on for a long time in various forms. It really took off in the 17th century. That goes under the name of science, and particularly the figures that you all know about: Galileo, Descartes, and especially Newton. But others too who are interested in questions um, like, what's up there in the sky that we look at. So you see the moon moving around and the stars and we now call the planets. Or much earlier, people were interested in life. I mean, of course, maybe the original scientists, although nobody really believes much of what he has to say about things now, was Aristotle. But Aristotle had, a big account of the nature of biological of life and of motion. Well, I think he got physics started in the sense that he made it clear that what physics was going to be about, where things are and how they move, and that's the idea that Galileo picked up on. Although Galileo's views about it were very, very different from Aristotle's, and Newton's ideas were. Well, Newton said he stood on Galileo's shoulders. Um, if you had Newton standing on your shoulders, you'd probably be crushed, at least intellectually. But Galileo was a great one too. So this activity science developed, and it really got going in the 17th, 18th centuries. The part of it that I know most about is physics, and to an extent chemistry and biology, and of course there are other sciences too. So it's basically thought of as being the fundamental science, which is physics, and then other sciences, which are sometimes thought of as special sciences, because they're about particular parts of the world, whereas physics is about all of the world at a foundational level. Chemistry is about the parts of physics that get to be molecules and how they get put together to form various kinds of what we call chemicals. Biology is about um, uh, the part of the physical world that gets together to form um, living creatures, whether they're viruses, I don't know if viruses living exactly, but bacteria, or paramecia, or cats, or human beings, or what lives in Australia? Wallabies in Australia, or in New Zealand? Or are they just in Australia?
We got a lot of sheep.
A sheep. Yeah, I know that's what it's famous for. It's a sheep.
We have a lot of sheep and cows. So really conventional animals.
No wildlife. They're kiwis, right?
Yes, they're the kiwi birds. And really only 2 weeks into living here did I discover that the kiwi was a bird. So that was important information.
Anyway, okay. So sorry to have the little side. I hope you can edit this.
Oh,
Anyhow,
I love the asides. Those are key.
okay.
Those are pivotal. So this
So
is included.
so this activity of science developed, and it currently it's an enormous enterprise. And there are many, many more scientists than there are philosophers. And so, for example, at a regular university like where I teach, Rutgers, there's a physics department, a chemistry department, a geology department, a uh, uh, biology department, of course. Probably is a meteorology department. I'm not even sure about that. But there are all these different sciences. Many, many people practice it, and they are trying to find out um, aspects of the nature of the world. So in geology, they're trying to find out about the nature of the Earth and what the Earth is made up of, as the structure of the Earth, and why certain events happen on the Earth, like earthquakes, or what volcanoes are, and so on. I mean, I don't know much about geology, so I shouldn't go on about it, but you get the idea. And similarly for the other sciences. Um, so philosophy looks at all of that and thinks, gee, what a fantastic, successful enterprise this has been. It really has succeeded in finding out about the world, a lot about the world, and in fact, even changing the world in many ways, because many of the things that science discovers has been, absorbed into technology and been used to produce things like automobiles and airplanes and to move people around, and television sets to keep people sitting in one place, and so on. So so it's this amazingly successful enterprise. And I look at philosophy of science as asking the question, what does the world have to be? What does reality have to be like for there to be this enterprise of science and for it to be successful? And what do human beings have to be like? And what are they doing to make it successful? So that would be my quick characterization of philosophy of science. Does that make sense to you?
Yes, I mean it I think is intuitive that it's taking a meta approach to science and asking questions about science itself rather than
Sure.
asking questions that science would ask. It's stepping back and saying, what is this discipline, science?
Yeah. I mean, I started off being interested in various sciences and various other things too, but I was interested in chemistry and that for a bit in biochemistry, and did experiments and even published a paper on one thing in that. Um, uh, but I found questions about the sciences more interesting than the questions that scientists were asking about the world. That's a little bit weird. So, and maybe this is a little bit personal, but you might find it interesting. When I was an undergraduate, I was taking a course in physics, and a course in statistics, and a course in history. And all of these subjects, the notion of probability or chance came up uh, in many different ways. And I asked the professors, well, what exactly is probability? What are you talking about when you talk about probability? And they said a few things which didn't hang together very well. They knew how to figure out what probabilities are, and they knew how to use probabilities in their theories and to explain things. But one of the teachers said, go to the philosophy department. They talk about what probability is there. So I did go to the philosophy department, and I did find a very good teacher there. And he said, yes, philosophy is very much interested in what probability is, but, and I think this teacher might have told me this quote that I really love. I don't remember where I heard it first, but it's from Bertrand Russell, famous philosopher. And Russell said, probability is the most important concept in science, especially since nobody knows what it means. That's what Russell said. So I thought I'd like to find out what probability is. And I spent a good chunk of my life as a philosopher trying to figure out what probability is. So I'm pretty interested in that question. Okay, so I think I've given you some idea about philosophy of science. As you said, it's a meta. It's about trying to understand what makes science successful, where the world has to be like to make science successful, what human beings have to be like, what do they have to practice, what are their practices like to make science successful, and and about the concepts that arise within the sciences and trying to understand them.
So there's that second function of philosophy of science, I take it, to provide conceptual clarification about specific concepts that appear in
Yeah, I mean, it's not just
specific scientific
clarification.
theories.
I mean, maybe I made it sound like that. I wouldn't say it's clarification. The scientists themselves better be engaged in clarification, otherwise they won't be able to communicate with each other. So what philosophy is interested in is something deeper than clarification. So when talking about probability, um, scientists have to know, for example, the mathematics of probability. They have to know how probabilities add together to make the probabilities if you have the probability of one statement, the probability of another statement, how to figure out the probability of their conjunction or their disjunction, and so on. So they would be interested in clarification in that sense. But philosophers are interested in the question of what are they talking about? What in the world makes probability claims true or false? And how do human beings go about knowing probability claims? Of course, the second thing is also a study of a part of science, because statistics. Statisticians are interested in coming up with ways of testing probabilistic theories. Okay, but they leave a lot of philosophical questions unanswered and on the table. Um, Also, like about why do their various methods in statistics work? What is it about probability that makes it the case that, as particular, I don't know what you know about statistics, but there are various approaches to statistics. Okay, so-called significance testing and things like that. What is it, and why does it work if it does work, or what's wrong with it if it doesn't work, and so on.
Mm. So then let's dive into a specific sub area within philosophy of science, the realism versus anti-realism debate.
Mm-hmm.
What are those two viewpoints about the nature of science, I take it?
Okay, so that's a really interesting debate. I was just reading a paper sent to me by one of my graduate students, actually, about that before we started talking. Um, Maybe I won't talk about that specifically because maybe it's a little bit too in-house. But so a good way to get into this is to think about Galileo. So Galileo was interested in the question of how the planets move. Everybody knows if you look up in the sky, you see at night, particularly probably in New Zealand where there aren't a lot of lights to bother you unless you live in Auckland or someplace like that. This full of stars, but there are also these other lights which move from place to place. The so-called planets, wanderers is what planet means. And what are they? People were interested in them from way back. The Greeks and the Chinese and people who lived in India and everywhere noticed them, and they were interested in what are they? And their motions are somewhat regular. So even Egyptians and the Greeks came up with tables to figure out where Venus will be from night to night to night to night over the year, where Jupiter will be from night to night to night. In fact, as you know, these planets were named after gods and goddesses. Venus was a goddess, and Jupiter was a god, and so on. So maybe they even thought that the planets were, in some way, um, godly things. But whatever, by the time Galileo was around, Galileo realized they weren't that. He realized they weren't stars either. He realized they didn't produce their own light. They reflected light from the sun. And of course, the sun is another body in the sky that everybody knows about. And it's obviously very important and central to the human beings on Earth. And the moon is another body that we see at night, which also reflects its light, whereas the sun produces its own light. So the question is, how do they move? Well, Ptolemy was a Egyptian Greek thinker back in the 2nd century. He had a theory about how they moved. He thought that the sun moved around the earth, some of the planets moved around the sun, and some of them moved directly around the earth as the sun was moving around the earth. And he actually had a theory which gave pretty good predictions about where you would see the planet from night to night to night. But they didn't give predictions that were quite perfect, and it was very complicated, his theory. He had to have actually the planets moving not just on orbits around the Earth, but on little cycles on their orbits called epicycles. I think he even has some epicycles on epicycles in some of them. So a Polish thinker in the 15th century, I guess, named Copernicus, came up with the idea that maybe everything moves around the sun. And he thought maybe they all move on circular orbits around the sun. He didn't know why they moved or how they moved the way they do, but he thought that maybe they do that. We'll get to realism era and non-realism in just a second. And he had a view about that, and that got modified a bit by a guy called Kepler, Johannes Kepler, a little bit later. Uh, and then Galileo modified it a bit more. But Galileo was really interested in motion. How do things move? And Galileo came up with an idea, which Newton picked up on, that we now call inertia, that bodies just move. Uh, a body that's moving at a particular velocity just will keep moving at that velocity in the direction it's going. It takes something to make it change its motion. So if a body's at rest, somebody's got to make it move. If it's moving, somebody's got to make it stop. And Galileo came up with some principles about how things move and came up with a view about the planets all moving in elliptical orbits around the sun, which gave pretty good predictions. But people in the church didn't like this view. Why not? Well, I'm not sure because I don't know enough about the theology of the times. But I think something like this, you know, people in religious institutions get used to certain views, and the idea that the earth was the center of everything seemed much more connected to what they thought of as, I don't know, the version of the religion of Christianity at the time, or something like that. And so they didn't like Galileo's view, which had the sun as being the center of the solar system. And I think Galileo even realized that the sun was just one among many stars. So this seemed to remove human beings from the center of things, whereas religion is right smack in the center of things. So now we're back to realism, irrealism. So Galileo had this view, and he was living in Italy at the time. Now a personal thing, I just was a month and a half ago in Venice. And in Venice is a big tower where Galileo demonstrated the telescope for the first time to people. And it's an amazing place to go to. I was up there. His telescope isn't there anymore. It's someplace else in a museum or something like that. But it's amazing to go to and think that Galileo was once in the same spot that I was at. And he put forward this view. But the church fathers at the time didn't like it. And they were politically very powerful. So they told Galileo to cut it out. You can't publish this view. In fact, they said, we're going to put you in some sort of prison or worse. Some people who put forward these so-called heretical views actually got executed by people in the church. So Galileo was made to publicly take back his view. And the story is that he had to go to some sort of a tribunal, and at the tribunal, he said he was supposed to say, no, everything moves around the earth, the sun moves around the earth, but he held his hands behind his back, and I guess he crossed his fingers. That's what we do now, and he said under his breath, "Il muove." They move. It really moves. The earth really moves. Okay. Now, what's realism, irrealism? Well, a realist thinks there's really a fact of the matter as to what's going on. Either the planets move in elliptical orbits around the sun, or they move in circular orbits around the Earth and on epicycles or not. An irrealist says, I don't give a bleep. All I care about is they get the right predictions. At least this is one kind of irrealist. Okay, so one way of being a non-realist about science is saying all you really care about is your scientific theories give the right observable predictions. This is sometimes called constructive empiricism, and its most well-known contemporary expositor is a very good philosopher of science named Bas van Fraassen. A realist, on the other hand, says, no, we're interested in something more than that. We're interested in what really is going on. And realists think that physics, by practicing physics, you can find out something about what there is really in reality, what there is really there. So physicists were really interested in what are things made up of, what are rocks and tables and human beings made up out of. And Newton came up with the idea that everything was made up out of particles in motion. And then later people came up with the idea that these particles, what you call atoms, which themselves had a certain structure and formed other molecules and so on. And so realists think that there's a really fact of the matter about it, and that these facts of the matter can be found out. We might be wrong about them, scientists might be wrong about them, but that's what we're really aiming for. And then there's realism about particular things. So one of the main concepts or ideas that physicists came up with, particularly in the 17th century, became very central and important, was the idea of a scientific law. Okay, that happens to be one of my main interests and something that I've written a book about. What is a law of nature? And so realists think there's a real fact of the matter about what the laws are. And there's a real nature of what laws are. Some realists about laws think that laws are something like entities over and above the ordinary things, which make things move around the way they move. When Descartes, who really popularized, I would say, is the right way to put it. I mean, he didn't popularize it in the way that he had a TV program or anything like that, but he popularized the idea that there are laws of nature, and that's what scientists should be busy finding out. He thought what the laws of nature were the principles that described how God moves everything around. Because Descartes thought that all motion was due to God moving things around. But God moved things around in a very orderly, principled, mathematical way. The reason Descartes thought that God moved things around in a mathematical way that could be described by mathematics is he thought that God must be very smart. And the reason he thought that is because Descartes was a mathematician. So like God must be like Descartes, I guess. I guess that's why I thought this. Okay, that's one thing he thought that laws were, the principles that describe how God moves things around. The other thing is that laws govern. Now, in some way, the idea that laws govern sort of says you can sort of take God out of the picture. Because if you got the laws there, you don't need God to move things around. The laws themselves move things around. So the idea of laws has these two aspects. Laws describe how things move around, and they govern how things move around. Now, both views are realist views about laws, although some philosophers think that only the view that laws govern is a realist view. I disagree with that. My own view is that laws just describe how things move around. We can get into that more if you want. But the main idea is that realists think that there's a real fact of the matter about the way reality is, and it's also, in some sense, independent of human beings. Although this actually describing in what sense it's independent of human beings is not the easiest thing to do. And a lot of the philosophical literature in realism is coming up with different accounts of what objectivity is and what independence of human concepts is.
So I do want to talk about laws, but I can't help but ask about my own initial impression when hearing of scientific anti-realism. Why would anyone be an anti-realist? I just have always thought it's so obvious that the intention behind scientific investigation is to get at the truth about the natural world. And that unless you were to espouse some wholesale global skepticism hypothesis, like we're all being deceived by an evil demon, you'd have to affirm that scientific investigation does at least some of the time latch on to the way the world
Well,
really
that's a
is.
great
So
question.
why would anyone be an anti-realist
Okay, so that's
or
a great
non-realist?
question, and I can give you some answers. I'm not an anti-realist, so I'm not going to
Well, good,
argue for
good.
the view. Okay, but There's something called a pessimistic induction, a pessimistic meta-induction. It said, look, when scientists have come up with theories that work pretty well to give right observable results, they've later made discoveries that refuted those theories. And that's happened over and over and over again. So they might come up with the view that you're never going to find out how things really work out. Nature is hidden. So the best we can really hope for is to come up with accounts which explain how things, which predict well, what we can observe, make accurate observable predictions. And after all, that's all we really have access to at first, is what we can observe. So someone might not be a skeptic because they might think, well, we're not brains and vats. If I see there's a teacup in front of me, here it is. Um, I have good reason to believe there's a teacup right here. On the other hand, if somebody says that the tea in the teacup is made up out of molecules moving around, how many molecules? Well, there's about 10 to the 20 something molecules of tea in here. I can't see those molecules. Why should I believe that? Well, the realist says you should believe it because look, believing that there are molecules moving around helps you make the predictions of things you can observe, like why the tea cools in a certain amount of time. Okay, and the anti-realist says yes, that makes a good prediction, but on the other hand, look, I can come up with other accounts of what's going on that makes the same predictions. This is another reason to be a anti-realist. Often when there's a scientific theory which makes good predictions, you can come up with another scientific theory. In some cases, they're real cases like this, which make the same predictions but look like they're saying different things about what there really is. And so if all we have access to is the observers, what we can observe, we'll never be able to tell which of these two different theories is the correct one. So this issue is really a big one in philosophy of science. Are there really alternative theories about what's really there that are really different but make the same predictions? And if there are, is there any good reason to really think that one of them is right or more likely or more plausible than another? That's called the problem of underdetermination. Does that make sense as a reason? So you asked a great question. Why would you might be an anti-realist? So I gave you two reasons. One is that theories that people have come up with have later been discovered not to work, not to be right, and that's happened over and over again. So why think that your latest theory is going to be right? And the fact that uh, uh, one of the examples of this I can talk about for a minute, and maybe you want to get into more, maybe not. But the contemporary physics, the central theory in contemporary physics is something called quantum field theory or quantum mechanics. Well, exactly what quantum mechanics is saying the real world is like is very, very puzzling. And some of the very early inventors of quantum mechanics. Should I go on about this for a minute? You might find it interesting.
Yes. Yeah. I have
Yeah.
a few questions about the arguments, but yeah,
Okay.
carry on.
Okay. So, as you might know, the reason quantum mechanics was thought up is that when scientists started looking at how electromagnetism, light, and atoms interacted with each other, the theories that they had then gave the wrong predictions. So they came up with an account that's called quantum mechanics. This is particularly so when talking about the structure of atoms. So here's to make it really vivid that anybody who takes a high school chemistry class knows, or high school physics class knows. Atoms are generally, on the whole, neutrally charged, but they can be made to be positively charged by knocking out the electrons around them. And so came to be seen that atoms had two parts: electrons, which are negatively charged, and then a nucleus, which is positively charged. And the positive particles in it are called protons. There are other particles there too, called neutrons, and other things too. And I'm talking about this in a very, as if I'm talking to my 11-year-old grandson, really. So I don't mean to make it too baby sounding, but but so so okay, but the theories about charge that people had then would say that the negative charge and the positive charge should attract each other. So atoms should just collapse. They shouldn't exist. They should. So there couldn't be, things like tables and chairs and rocks and human beings, because the particles that make them up would just collapse because the protons and the neutrons and the electrons would attract each other, but they didn't. So what's going on here? So so this issue plus issues about how electromagnetic radiation was being emitted by atoms when they were under certain circumstances led to development of rules. They looked at, in some ways, they were like Ptolemy's. What I was telling you, Ptolemy's theory of the planetary motion was like. They were just a bunch of funny rules which gave right predictions for a while. So, in particular, there was a scientist, very famous and apparently very charismatic, guy named Niels Bohr from Denmark, and he had a bunch of people around him, and he came up with a theory of the atom and the structure of the atom, which was pretty good as far as making predictions about what kinds of atoms there are. So, as you know, there's a periodic table, which is hydrogen, helium, lithium, and so on in the atoms, and they differ from each other by how many protons they have and how many electrons they have, and how many electrons are at various levels in the orbits or around the nucleus. Shouldn't say orbit really, though that's the way it's often taught. So here with this theory, and it was, like I said, it was like Ptolemy theory, a bunch of funny rules. They give good predictions. But one of the other famous scientists at the time, probably the greatest physicist who ever lived, I bet you can guess his name.
Albert Einstein.
Good guess. Okay.
That's the only one I know. Just kidding.
Right. Well, actually reading things that Einstein wrote, you realize this guy was a great man. Okay. I never met him, of course, but and I'm not saying anything that a lot of other people wouldn't say, but he was a human being too. But when I think about human beings, and I think about some of the human beings that have been walked the earth and how horrible and evil and destructive they've been, I then also think about other people that human beings have produced, Einstein, Mozart, people like that, and I think, well, there can be a lot of different kinds of human beings. Einstein apparently was generally a pretty good person too, in general. But I don't know. Just the stories about him. Okay. In any case, he was a realist. He thought, I'm not satisfied with just a bunch of rules which makes predictions about what I will observe when I shine light on certain kinds of atoms, or gives me certain predictions about what kinds of atoms or chemicals are in the periodic table. I want to know what's really going on. So Einstein was also a contributor to early quantum mechanics. Then there were two major figures who really put quantum mechanics on a mathematical footing. One was a guy called Werner Heisenberg, who was an associate of Bohr's, and he more or less agreed with this kind of anti-realist view. He had a very, very complicated, complicated, but it's often taught, account of giving of quantum mechanics, giving the account of what would be observed under various circumstances. And the other one was Erwin Schrödinger, who was more like with Einstein, and he was an Irish physicist who wanted to have an account of what's really going on. So they developed quantum mechanics. And the interesting thing is that while Schrödinger's general equations, well, both of them have ways of dealing with it, is what's taught in physics courses for years and years and years. And of course, it's gotten much more sophisticated and complicated over time as quantum mechanics extended the domain of what it can make predictions about the larger and larger molecules and and so on. Um, uh, Physicists in general kind of lived with a more or less anti-realist view about what they were talking about. They really weren't exactly realists, partly because quantum mechanics said funny things about the particles that that made up matter. For example, they said that an electron might not have any location at any time. It might have, to the extent it has its momentum becomes more and more localized, its position becomes less and less localized. And they meant by that not just that you don't know where it is it doesn't even have a position. Now, if you stop and you think about it for a second, so I said, what kind of particle could it be that's not located anywhere? And how could it be moving with a particular velocity if it's not located anywhere? That's a real head scratcher. But the reason they got away with it is that when they did experiments which would tell them what its position is or what its momentum is, they could do experiments and they would get results. But the theory told them you could never do an experiment which told you what the position and the momentum is at the same time. The theory itself said that. And so they came to live with this. And so a certain way of thinking about quantum mechanics got to be called the Copenhagen interpretation after Bohr, who was from Copenhagen, which was a rules for how to live with this weird situation. But other physicists were not very happy with this. Einstein was very unhappy with it. So he tried to come up with arguments to show that the Copenhagen interpretation can't be right. And one of the most interesting things to study is an interchange between Einstein and Bohr. I'm not sure they ever got together to talk about this. I know they saw each other place, but I don't know anything about conversations they might have actually had. That would be really interesting to know about. I just don't know enough. I should, but I don't. But Einstein wrote a paper, actually, a couple of his associates wrote a paper trying to prove that it was incoherent to talk about particles not having positions and momentum at the same time. And it's very interesting, the story about this. His paper is called the Einstein-Podolsky-Robertson paradox, or the EPR paradox, because quantum mechanics predicted that there could be two particles, two electrons, which were in a quantum state such that their positions were correlated with each other. If one of them was in a certain location, the other one would be in that location. And if that other one was in a slightly different location, that other one would be in a slightly different location. And the momenta would also be correlated with each other. So Einstein thought, look, these particles could be far away from each other. Maybe we could measure the position of one of them, the momentum of the other one, and then we'd learn about the position and the momentum of both particles. Do you understand? I'm telling you a very rough description of the EPR paradox. Okay. Well, it also turned out that if you could do this, since the particles were very far apart from each other, the quantum states of these particles would change instantaneously, and so faster than the speed of light. So Einstein thought there must be a conflict between his own theory of space and time called relativity, which said nothing could travel, no information could be transmitted faster than the speed of light, and no body can move faster than the speed of light, and quantum mechanics. And this was and Bohr replied to this, and it turned out there were ways to reply such that you really don't have a real contradiction. Most physicists just let it just stand like this. They didn't really investigate this much further until sometime in the 1960s, when another great physicist, but one whose name is not so widely known, I'm going to ask you whether you know who he is John Stuart Bell?
Yep. Yep.
Okay. He's famous for a thing called Bell's theorem. So he looked at this very carefully, thought about it very, very hard. And I did meet Bell in my life, and it's one of the great experiences that I have actually personally had. I mean, he didn't know he met me, but I knew I met him. Um, I can tell you more about that if you wanted to hear. But and he looked at this very carefully. He wrote a number of papers, which are great to study and read now, the APR paradox. And he realized that he could simplify this argument of Einstein, Podolsky, and Rosen's. He did in a very simple way. And he realized then that quantum mechanics is going to give certain predictions about the probabilities of finding the position and the momentum, or he did it for a feature of that electrons have called spin, finding the spin of these electrons, the probabilities of that you get of measuring spins in various directions of these electrons. And he realized that the quantum mechanics predicted that the probabilities that you'd get were incompatible with the electrons having the definite spins in all directions, or in the position momentum case, having positions and momentums at the same time, unless there's some sort of correlation between them that's there in the, that happens in some sense instantaneously. Of course, non-local, instantaneously doesn't make any sense in special relativity, but that's what Bell realized. So he realized there was some sort of interesting thing going on there, and he gave a very simple little argument called Bell's theorem. I teach it to undergraduates. It's very simple to teach to someone, just a little proof in algebra, to show that if quantum mechanics is right, particles can't have determinate position and determinate velocity or determinate spins in all directions at a particular time. Yet their spins are correlated with each other. It turns out that it doesn't really violate relativity, because when you find out the spin of one particle, it's not going to really tell you what you're going to find out about the spin of the other particle. Okay, something funny is going on there. So no information literally is transmitted faster than the speed of light, but there is a superluminal correlation, or an instantaneous correlation. This, I think, is one of the greatest discoveries of the 20th century, that the universe is non-local in this way, that what's going on in different places is correlated with each other. In fact, our whole universe is like that, because the quantum state of the whole universe probably has pretty much everything correlated with everything else in some way or other. And that's what Bell showed. Now, I didn't describe it in a precise or exact way, but I give you the gist of it. Now, can you be a realist about this, say what's really going on? Well, Bell thought maybe you could, and he realized that there was another physicist who came up with an account which was a realist account, in which there really are particles, and electrons really are particles. They really have positions of momentum at all times. And there's a quantum mechanical wave function that also is correlating their positions and momentums at all times. Now, exactly what the wave function is, on this physicist's name is David Bohm. I don't know if you know his name or not.
Sure. His
Okay.
Boman Mechanics, the
Boman Mechanics,
pilot wave theory of quantum
So
mechanics.
you ran into all of this stuff. So, okay, so I shouldn't be talking like I'm talking to my grandson. My grandson wouldn't have heard about it.
No, but my listeners might be like your grandson. I don't know,
Okay.
so that works.
Okay, so Boman Mechanics is a realist understanding of quantum mechanics. Now, it's not widely taught in physics departments, but it's a way of understanding what's going on in quantum mechanics in a realist way. It says there really are particles, they really are positions of momenta, they really have all the parts, well, really have positions, since it's really important at any time. But there's also this thing called a quantum mechanical wave function. Now, the next question is, what is this quantum mechanical wave function? Now, that's a big issue. And Bohm had a kind of funny view about it, which I'm not going to get into. But philosophers of physics now are very interested in coming up with a view about what is the quantum mechanical wave function. Where is it? Is it something like a law that correlates the motions of particles in this governing way that I was talking about laws before? Or is it some part of reality? If it is, does it exist in ordinary three-dimensional space? Looks like it can't, actually. So maybe it exists in a very high-dimensional space. That's a certain view. It's a view that I kind of find interesting. I don't know, say I think it's true, but it's interesting. But a realist thinks there's a real matter of fact about this, and is looking at different proposals, and then wants to have a bunch of, see what the proposals are that give right predictions, and then tries to evaluate the different proposals to see which ones make sense and which ones don't. And maybe in the end of the day, there'll be more than one proposal, and you won't be able to have any reason to prefer one rather than the other, in which case you end up saying, I'm a realist, it's a real matter of fact, but human beings just won't be able to find out. That's I think, what the real situation is about reality.
That there is a fact of the matter, but we won't be able to find out.
Yes. Um, I mean, I have a somewhat way which I would like to modify that in some ways, because I think it's a fact of the matter. Yeah. Okay. Let's go. Let's go with that. I won't modify it because it get too much into the weeds. But yes. So there is a fact of the matter about what there really is. So what is physics interested in? It's interested in answering the question: what is there? What is everything made up out of? In such a way that you can give an account of the things we can observe. So when you say what there is, it'll you'll be able to also say that this is the stuff that makes up rocks and tables and chairs and cats and human beings and clouds and stars and so on. And what do all these things do? Well, they basically move around. So physics is going to give an account of how things move around. Okay. Maybe they do some other things too, but the other things they do also are also going to be very much connected to how things move around. So physics is about what there is and how these things move. And is really, this idea was in Aristotle, sort of. I wouldn't say put it exactly I did, but definitely was there in Newton and um, and thinkers in the 17th, 18th century. And it's definitely what physics is about now. And then the question is, most of a lot of what philosophers are interested in is giving an account of how the various sciences get connected to each other. So, of course, biology talks about very complicated physical things. So, a cat is made up of a lot of different kinds of molecules. I happen to like cats. Unfortunately, my cat died a few months ago, so he's not going to be here now. He's a very nice cat. His cat. I'll get another one when I finish mourning this cat. But um, uh, I don't have his photo on the wall here, so I can't show it to you. But anyway, but a cat is made up of something like 10 to the 23rd three molecules in various, very complicated connections to each other. Now, I don't think that's a very large number, 10 to the 23. So no one's ever going to give a real account of how, in detail, of how the motions of these fundamental physical things, and of course molecules themselves are made out of more elementary things, and ultimately quantum mechanics is the fundamental theory anyway, about all of this. No one's going to give an account in detail about it, but you want to have some idea about how atoms and molecules moving around in various ways can give rise to cats running around and catching mice, and give rise to mice trying to get away from the cats, and so on. Okay, so biologists may study cats and mice, but they won't be so much interested in, yes, about what philosophy is science about. and bring up another answer to your question, how the in different levels of science, so to speak, are connected to each other. So um, biologists are interested in 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 cats and and mice and all sorts of other living creatures, and physicists are interested in what they're all made up out of. But the question of how did the stuff that they're made up out of actually make for cats and mice moving around is a really interesting question. And when you come to living things, it really gets puzzling because the fundamental laws of physics, on the one hand, they say things how move around, but what they seem to say seem to be incompatible at first with there being life. This isn't true. It's not incompatible. But one of the laws of physics is, you probably have heard about, is the second law of thermodynamics. You've heard about that, right? You know what that is. So that says basically that in any system that's isolated, a quantity called entropy will be increasing. The entropy of the whole universe is increasing, and what that basically means is that the energy that is available to do work gets less and less and less and less. And it also means that things get more and more, so to speak, disorganized. But living beings are not like that. Living beings get more and more organized during their lives until they die, then they get disorganized. But um, now, why is that? Well, because human beings, living not just human beings, but all living beings, are not isolated. They interact with their environment, and there is a source of energy that living beings interact with that somehow enable them to keep their entropy from going up, even lower their entropy, while the entropy of their environment goes up. What is that source of energy, incidentally? Do you know?
The sun?
Of course. So you're good. Okay.
I was sharp.
Okay. So, but it's still a question. And it's a question that interests me a lot. And I don't think there's anything like a really, really good answer to it. The physicist I mentioned to you earlier, Erwin Schrodinger, wrote a book called What is Life? Now, he wasn't a biologist, but he realized there was this sort of conflict between the second law of thermodynamics and there being living beings. And he showed that no, there's not a real conflict. But the question is, what is complexity and how do complex beings form? And how is this compatible with statistical mechanics, which is what underlies thermodynamics? That's a really, really interesting question. And I don't think that there's progress made and things that people say about this, trying to understand what complexity is. So, but I don't think anything close to being a accepted view about this, at least not one that I understand. So that's one of the open questions about connecting physics and biology that could interest a philosopher a lot. I'm not sure that I will know enough to really. I'm very interested in it now, and I've been interested in it lately, but I don't know if I'll ever know enough to really make any progress myself on this. But it's quite an interesting question, and there are people who've written interesting things about it. Okay, so do we have an idea now what philosophy of science is?
Yes, that is helpful. So
Because you look sort of
let
overwhelmed. And
no. I'm overwhelmed with potential lines of inquiry and different questions I could ask. But
ask
let's
questions.
follow
I
this.
should shut up.
Let's follow this thread a little longer. I'd rather do fewer topics, but go deeper into each. So we have these two arguments for anti-realism that we've floated: the pessimistic induction and the underdetermination of theory by data. So with respect to that first one, I have heard the common realist response would be something like this: that the progress of science, that the history of science doesn't reveal the creation and subsequent entire destruction of scientific theories to be completely replaced by another one over and over and over again, because that would lead to an induction that if all past theories of science have utterly failed, well, these ones probably will too. Rather, what it seems to indicate is merely the limitations of prior physical theories. So when Einstein proposed his theories of relativity, they didn't dismantle Newtonian mechanics entirely. Rather, Newtonian mechanics was still a correct description of the physical world up to a point. Once you go near the speed of light or are entertaining very large masses, well, then you need general relativity. But for lower mass objects, lower speed objects, Newtonian mechanics is still correct. It's just that it wasn't the entire truth or the complete description of the physical world.
So
And so
what you
that,
just said, there's a lot wrong with what you just said.
okay, okay.
Okay. Okay. First of all, it's not general relativity; it's special relativity. But that's a small point. But Einstein relativity did dismantle Newton. What's right about what you said is that the predictions made by special relativity agreed with the predictions made by Newton as long as things weren't moving very fast. But the structure of space and time was very, very, very different. It dismantled that entirely. Okay. So, for example, for Newton, space was one thing, time was another thing. Newton thought that space was, something like a container which had a Euclidean geometrical structure. It was a matter of fact about the distance between any 2 points. And so, if there were two particles, what their distance is depended on which points they were located at and how far apart those points were. Okay. And if you had three particles, they'd form a triangle. And if it was a right triangle, there'd be the Pythagorean theorem would hold. And for any triangle, you have to add up some of the angles, the degrees of the angles. It would add up to 180 degrees. Einstein said, no, space and time can't be separated like that. Let me go on a little bit more with Newton. Newton thought also, like many people think, that time is fundamentally different from space. Time, I don't know, what do people say? Time passes, it moves, right? Is that what they say? Do you think time moves? Is that what you think?
Well, I would hold to a theory of time closer to that, but they would say that's a metaphor, right? That time can't literally move, but things really do come into being and pass out of being. And so it would be to disagree with this view that sees time and space as linked up into one space time.
So that Einstein's view is that there, time and space are not two different things, at least initially. Now you can eventually separate them in some way too, but there's space time. Furthermore, the structure of space time is a very different kind of geometry. In general relativity, the geometry really depends on the matter that's located in space and time. So geometry can change, and it can change, so to speak. You're located one place. As you're located there, the geometry around you can change at different times on your clock. So for Einstein, there is local time. I can have a clock that keeps track of my time, and a friend of mine can have a clock that keeps track of his time. And if we go distant from each other, well, it no longer becomes sensible to ask whether things occur at exactly the same time for both of us, because time depends on where you're located as well. So that's what we were talking about before. There's no such thing as instantaneous within Einstein's initial theory. Now, it's possible to soup up his theory so that you add an instantaneousness to it, and you might have to do that within certain versions of quantum mechanics. But that's what we were talking about before. But well, let's see, what should I say about this? In any case, um, I would say Einstein completely jettisoned Newton's theory about space and time, although the empirical results, as long as you weren't moving very fast or as long as you weren't in very strong gravitational fields, would be exactly the same that Newton gave. Or not exactly the same, but close enough so you couldn't tell. Okay, so the empirical result, empirically, was right. So that's just like the constructive empiricist or the anti-realist. So the anti-realist would say, no, this is a good example to show why anti-realism is right, because Einstein did completely not kick over what Newton said is really going on that you can't observe, while preserving the observable predictions of Newton in, under special circumstances, as long as you weren't moving too fast, so the gravitational fields weren't too strong. You see why what I said you said is wrong?
Yes, yes. No, that's an important correction. And I can see why the typical response of so the general point I was getting at that I've heard from realists is that the progress of science just reveals limitations of prior theories in general rather than dismantling them entirely. That's going to be harder to defend in the case of Newtonian mechanics because the the ontology or the core claims about the world within a Newtonian framework is absolute space and time. And that
Yeah,
is
but
exactly what
it
Einstein's
was
theories.
dismantled, and same with quantum mechanics. Quantum mechanics completely dismantled um, the Newtonian theory of particles and what things and how particles move around and so on. So um, it might be possible to interpret quantum mechanics as Bohm did, so that it looks a little bit more like Newtonian mechanics, but it really is very, very, very different. So I would say this is dismantling. Now, this is what the great example in the history of physics, and it's really about the most fundamental theories. In other places, maybe what you said is closer to being true. So I'm not sure exactly what to say now in some other places, and where in biology, um, genetics, people had a certain view about how traits were transmitted from one cell to, to, to children's cells and so on, or from parents to children. But they didn't really have a good idea of the detailed mechanism. Okay. But I'm not sure that change, what you would call a complete dismantling. It was more filling in the details. Okay, but that wasn't fundamental science. That was in a special science, and I think a good question, and you just raised it. Why don't you study it in graduate school? Because I don't know what to say at the top of my head. Is those cases where changes in scientific theories are better called dismantling while saving predictions to an extent. So there are three kinds of changes that can make. Some scientific theories just gave wrong predictions, like Aristotle's theory about motion. It just gave the wrong predictions about how things would move. Just nobody bothered to do the experiments to see that. Okay. Okay. Sometimes some theories just get thrown out because they give bad predictions, even in the ordinary domain. Sometimes they get thrown out because their fundamental ontologies are wrong, so they dismantled, like we talked about in Newtonian mechanics. But sometimes there might be cases in which, no, the fundamental ontology just gets refined. Okay, and I think I could see that occurring in special sciences where it's not fundamental. And it would be interesting to go look at some various case studies. Uh, so clearly the idea about how life on Earth developed, if it did develop, really changed radically when Darwinian evolution came on the scene. Um, but there are elements. The other viable theory at the time was the idea that traits that were acquired were inherited, that Lamarckian uh, theory. And most biologists think that Lamarck was completely refuted. That's probably not exactly right, but uh, but that would be a case of a rejecting of how one theory worked completely in favor of another theory. Um, if that really is the right way to put it, you need to talk to a philosopher of biology to really get into the nitty gritty of that, or a biologist.
So does this argument go wrong then, in your view? Or is this a good, successful argument for anti-realism?
Well, here's the thing about philosophers. Where did I read this just recently? Recently, somebody wrote a line that I kind of like. Philosophers don't agree about anything except what I just said. Okay. Okay. So I think what you have in philosophy is you have arguments, and you have counter arguments, and counter arguments. And sometimes what happens in philosophy, this is something I encounter a lot as a teacher. Sometimes you look at it and you look like progress is being made because you get deeper and deeper understanding. And sometimes it looks like people just digging holes. And particularly if you have graduate students and they learn to give counter arguments to counter arguments to counter arguments, it sometimes looks like the latter thing is just happening. How to tell one from the other, I don't know. You only, you know, understanding is a somewhat personal thing, whether you understand things better than you did before. But yeah. So okay, so I don't really know. If somebody asked me, which is right, realism or anti-realism, I guess I would say I'm not an anti-realist about it. I think there's a matter of fact about it, but I also think that maybe there's no conclusive argument one way or the other. There are arguments for or against each of these views and counter arguments and refinements of these and so on. And that's what you study if you go to graduate school in philosophy of science. Um, but it may be discouraging to learn that you may never come up with the truth. Well, that's not exactly right, because you can see some places where views that people held in the past now nobody takes seriously. Maybe they will again in the future, but so sometimes, um, really there are arguments that are so good they refute other arguments. So I can think of some examples of that, but other philosophers would disagree with my examples of that. So then let's not won't be that conclusive. But here's an example. I think that one of the great philosophers for me in the history of philosophy was David Hume, and David Hume allegedly gave. I don't think he did give this, but it's been now put in various forms by subsequent philosophers. An argument that there's no way in which you can give a non-question begging justification of what's called inductive reasoning. I think Hume was completely right about that. Okay. Nevertheless, you can find many papers which philosophers think they were refuting Hume about this. Okay. Um, but I think they're wrong. But that would be one example where I think a philosopher definitely showed something that's right. Now, that doesn't mean that we should throw up our hands and stop making inductive inferences. Not at all. Doesn't mean that. It just means that we got to do it uh, with the idea that there's no non-question begging justification of any system of inductive inference we use. There's some systems of making inductive inference you can show that are better than others, because you can show that some will end up being more accurate than others by using other things that you accept, or some are inconsistent, lead to inconsistencies. So those think will be good, because those tell things that are definitely untrue, because we know inconsistencies aren't true. So there are ways of arguing for or against various ways of making inductive inferences, but no non-question begging justification of inductive inference. And that's another thing one would study in philosophy of science course.
That actually is. It's come up recently on something I'm working on for a paper, is the problem of induction, and specifically this underdetermination of theory by data. So it is the case, I take it, that you can make any theory compatible with the result of an experiment or empirical observation by making it more ad hoc, more contrived, by tacking on more and more claims. You can render any theory compatible with observation. So,
Well, I would say that's a pretty broad claim that any theory
hmm,
you could do that with, but there are many examples where you could do that. Yeah,
fair.
right.
So, what is the realist response to that problem?
Well, go back to Einstein. I don't. I think Einstein was a man of faith. Not to say he believed in any particular religion. I don't think he did. I'm not really sure about that. But if you're a scientist and you're a realist, you have to be a person of faith. You have to think that, look, we've been successful so far to an extent, by using various methods of inference and construction of theories. One of the things that we learned is that by doing this as sort of ad hoc business, we just end up with ugly theories that really don't make good predictions anyway, and their explanations aren't aren't good because you want a good theory to stick its neck out and make predictions. But if you've come up with a theory which has a sort of built-in ad hocness to it, it's not going to make any new predictions because it's going to fit anything, no matter what you observe. So you want your theories to stick its necks out. The philosopher of science who most famously argued for this was a guy called Karl Popper. You've probably run across him, and I think in some ways he's greatly overestimated, but he was certainly right about this. We want theories to stick their necks out, and one of the things that we want in a good theory is to make claims about the world that we can test. And if it passes the test, great. Then we have some reason to think it might be on the right track. If it fails the test, we have reason to think it's not on the right track. Now, we might then modify the theory sometimes, and we come up with another good theory, which is on the right track. But if we build into the theory some way in which it gets modified so that it's going to fit no matter what happens, then that's not going to be a good theory because it's not really sticking its neck out.
I wonder, though, obviously the anti-realist can press that if you can modify a theory that, say, was falsified by some experiment, it predicted X, but we observed Y. But we could tack on an additional claim, make it a bit more contrived, a bit more ad hoc, add the epicycles, so to speak, and the epicycles on epicycles. And now it's
Mm-hmm.
consistent with our observed results. Well, fine. It didn't stick its neck out. This revised theory doesn't predict future observations, but in the sense it predicts the past observations. And why is that any worse? We still want to know why we should prefer a
Because we
simpler
want
theory
theories
that directly predicted data versus a more complex one.
because scientists want theories that stick their necks out. It's just a theory. I
Mm,
mean, we're using a metaphor here, but
sure, right.
okay, okay, and in this, and they want theories also that are simple. Okay, so
Mm, mm.
one of the ideas is that the faith that 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 I mentioned earlier that Descartes had, that the universe could be described in a fairly simple mathematical way. Now, of course, you might need very sophisticated mathematics before it looks simple. Okay, so I mean, to somebody who hasn't learned, you know, uh, uh, calculus, uh, Newtonian mechanics may look complicated because the mathematics you need is differential equations. Um, and somebody who hasn't learned um, uh, tensor mathematics is going to find general relativity very, very complicated. And in fact, in some sense, it is. In some sense, it's very simple. In some sense, its mathematics is complicated because it's very difficult to solve equations in it to actually get the empirical results out. So the mathematics gets developed along with the theory, along with scientific theories, in order to have simple theories that look simple. So you want theories to be simple with the idea that they're that with the faith that there's a simple mathematical theory of what there is fundamental. Now maybe this is wrong. Okay. Anyway, but you're asking an interesting question. So the idea of mathematics, but this is not right of all of mathematics, but a lot of mathematics developed in companion with parts of science. The science developed, particularly physics is part I know about, but other parts too. Um, in order to come up with simple mathematical descriptions in the mathematics, even if to somebody who doesn't know the mathematics, it's going to look very complicated. So you got to learn the mathematics, and it's still going to be complicated to extract observational results from the mathematics. That's what happens in general relativity. Now, in current physics, I don't know nearly enough about this, but my wife's brother is a string theorist. You know about string theory? So I talk to him sometimes about string theory. And there, the mathematics has gotten very complicated. so complicated that there are many, many versions of string theory. So underdetermination runs amok. There are many, many what looks like different theories making different claims about what there is fundamentally there, and no way to empirically test that one is better than the other so far, and very difficult to extract observational, experimental results from them, and so on. So this is a bit of a crisis in this part of foundational physics right now. Um, but this is you ask you're going to turn me into an anti-realist, you know, and but this would be a reason to get worried. Um, that maybe there isn't a simple description of the world, and there are philosophers. I'll mention ones as we're just talking about who think that the whole idea that nature has a simple description at a fundamental level, and then the other sciences sort of sit on top of the fundamental level. That's the description I was giving you before. Is all wrong. What there are is we can describe the world at different levels, and they don't fit together very well. And sometimes this is called a dappled view about the world. And the philosopher who's best known for having a view like this is Nancy Cartwright. And, so she thinks philosophy is like my office. I'm sorry, the reality is like my office. It's just a mess, and it can't be put into order. Um, but while my office is a mess, I think reality is. I'm a realist. I think it is a simple mathematical description of what's there fundamentally, then everything else will fit into that in some way. Although showing how it fits together might be a very complicated and difficult matter.
Well, so in that case, let us zoom out, and I'm curious to hear your take on a very general question. What is the proper relationship between science and philosophy? Because I don't think philosophy of
Between
science
science and what?
necessarily. What is the proper relationship between science and philosophy? How do they relate? I think that philosophy of science is part of the answer to that question, but it's not the whole answer
Well,
because there are other areas of philosophical investigation that might be relevant to science, and it's not clear. It's not always clear
science and philosophy.
which one is most important and which one leads in the search for truth. That's a
Well, different things would
specific
be
way of
important to
stating
different
it.
people at different times. And of course,
Yeah.
if you were, scientists ought to be interested in how they treat other scientists.
Hmm.
She shouldn't lie to them, maybe, or something like that. And you might wonder why you shouldn't lie. Is there some reason you shouldn't lie? And how can you, is there some general way of characterizing what principles there are in ethics? And I don't know whether you could, whether there's a matter of fact about what other ethical principles are right or wrong. That would be a realist about ethical principles. That's not my field. I'm not going to stick my nose in there right now. Um, But so, and scientists should be interested in that like everybody else. And there are particular issues in ethics that come up in parts of science, like in bioethics and so on. But I think you had in mind something a little bit different. At least that's what I took at first. My immediate response to your question of how does philosophy and science relate is that usually if you're a philosopher and you walk into a science department, you go to a party and there's some scientists there, and they're talking, and you say you're a philosopher, they turn away and they don't have anything to do with you. Now, not all scientists are like that. Many now aren't, and there are some physicists who are very interested in philosophy. Einstein was one, for example, and he knew a lot of philosophy. He thought philosophically. I'm not sure he studied philosophy so much, but he thought philosophically. And there are many others. There's people, guys who have podcasts now. I can mention. Who Sean Carroll is. Yeah, yeah. I mean, so he has a podcast. So I know him. I've done a podcast with him, and he's very philosophical. Uh, um, okay, okay. But in general, most scientists don't want to answer philosophical questions about it. Like I told you, when I got interested in philosophy, I was taking a physics course, and I was asking the physics teacher, but what he meant by probability, and he really couldn't come up with good answers. So he sent me to a philosophy department. They don't want to be bothered with that question because he's bothered with coming up with accounts of what is the probability of a radium atom decaying in a certain amount of time. He'll come up with an answer to that question, but he won't come up with a question of what is probability. So here's the way I sometimes like to put it. Physicists are interested in what particular the values of particular probabilities or what laws there are. Philosophers of science are interested in what probability is or what a law is. So it's interesting things, what are laws as opposed to what laws are. What are probabilities as opposed to what probabilities there are. Okay, so that's one connection. So now philosophers, if they're philosophers of science, they want to find out something about a science. Now, like I said, I've had some training, so I know something about physics, but I couldn't, you know, I probably couldn't pass a, well, not probably, I certainly couldn't pass, you know, a prelims in the physics department for a PhD degree. Probably couldn't even pass an advanced, you know, uh, test in general relativity now or quantum mechanics. I just can't solve those equations because that's not what I've been doing. But I do understand it in a way. So I haven't understood. So if you're, but I think if I was better, I would be understand the physics better than I do. And if I was a philosopher of biology, I understand the biology better than I do. I just read a book by a philosopher of biology, and she really got into things in great detail. You know, so she knows, you know, what all the amino acids and all the different kinds of viruses there are, and so on and so on. That's something that, you know, if you're a philosopher, when I was reading the book, a lot of that information came up in the book, and I didn't bother to even read those pages very carefully because I don't want to fill my head up with that information. I have enough trouble remembering what I'm supposed to do today. Um, okay, so I don't want to fill my head with that. Okay, but if you want to be a philosopher of biology, you might need to know all that stuff in order to reflect on the nature of biology. Okay, so philosophers of science need to learn science up to a point, but they don't want, but they're not going to become scientists. They're not going to do experiments. Uh, so philosophers don't do experiments. There is a part of philosophy called experimental philosophy, which philosophers are interested in sort of, sort of in a way, experiments about what people would say in answer to certain questions about, you know, so in order to investigate the concepts that people ordinarily have. Okay, or something like that. It's not what I do, but it's with something. But in general, philosophers don't do experiments, whereas parts of scientists do experiments. Not all scientists. My wife's brother is a string theorist. I don't think if he went into a lab, he probably knocked over the lab equipment. I don't think he knows. Uh, he doesn't do experiments. Um, so theoretical physicists won't do experiments. Okay, but a lot of science does do experiments. That's not the method of philosophy. Philosophy does make progress by doing experiments in general. But philosophers have to learn a bit of science if they're going to be philosophers of science. Scientists don't have to learn any philosophy in order to do their sciences well, for the most part, until they run into a problem. Sometimes if they run into a problem where some of their concepts collide with each other, you have to think about it a bit. Like when quantum mechanics and special relativity collided with each other, they seem to be an incompatibility. They have to think philosophically about how to resolve that incompatibility. That's the sort of thing that philosophers of science or some scientists might think about in a philosophical way. Okay, but in general, scientists don't have to be philosophers. Um, but I wouldn't say there's a radical difference between the way they think. Both cases, people are thinking by putting forward ideas that are supposed to just describe what's going on in some way, and then trying to work out whether those ideas are right or wrong. Philosophy is more figuring out whether they're right or wrong by connecting them with other ideas and using logic, and scientists have this other method of connecting things up with the world by doing experiments. Okay, but that's a really good question that you asked, and a good thing to try to figure out. I just was at a talk given by a philosopher, and she wrote a book in which she said philosophers should really adopt the methods of science more. And it was a little bit hard to figure out what she meant by that. And she didn't think that they should do experiments. I think I'm not really sure, so I'm not going to say anything more. I can tell you if you want to read her book. I can tell you what her name is, Nina Emery, and it might be an interesting book to read. But uh, um, but one thing you might look at is to try to be clearer about what are the methods of philosophy. There might be a number of things you might identify as methods that philosophers use when they think and write papers and argue with each other, and what are the methods of science in order to make progress in either field. And that would be a good thing to try to come up with a nice, clear account of. I don't have one off the top of my head.
Let me ask you a question about a specific potential philosophical scientific conflict, because that'll help uncover, I think, what your underlying view is about the relationship between the two. Suppose that you're convinced on philosophical grounds that the so-called A theory of time is true. This would be like our commonsensical, perhaps
Right.
pre-Einsteinian
It's a
theory
great
of
question
time,
you're asking. Right.
that things come into being, things pass out of being. The past is no longer real. The future is not yet real. Only the present moment exists. And this view, a specific form of the A theory, is also called presentism. I think most people roughly, readily have this view of time. But then Einstein's theories of relativity ostensibly call this theory into question, or they refute it entirely. They seem to lend themselves more to the so-called eternalist theory of time, that
Mhm.
past, present, and future are all equally real, among other things. But suppose that you have really or in your own mind, have really strong philosophical arguments for a presentist theory. They're not scientific, but they're philosophical. Does that give you reason to reject Einstein's theories, or at least the conventional interpretation of those theories? Or
It
is there
could,
something illicit about relying on philosophy to adjudicate
so
science?
so many philosophers, and this person I mentioned earlier was saying that philosophers should adopt the methods of science. She was saying, and many philosophers would say, and I would say too, that philosophers should pay attention to what scientists say about what there really is. But of course, that doesn't mean that you might have reasons to say the way they are understanding their theories is not right. Now, in fact, I know that you can be a presentist and still hold Einstein's theory of relativity. I'm not like that. I also disagree with what you said that presentism is common sense. I do think people, yeah, presentists say that, but it's not. It's not really common sense. But because you're using words that you got to pin them down, like real. What is real? What does he mean by real? Okay, okay. I mean, do you mean by real that what exists right now? And then, of course, you're a present. Okay, but and in fact, what in the world could that really mean? Because I also think that what's real is things that are outside of this room, and maybe things that dinner that I'll have later, and things or dinner I had yesterday. I think these are perfectly real. Okay, now it's right that Einstein's theory of time and space kind of like pulls the rug out from the way presentism is usually described, because there's no such thing as now in different places, as we were saying before. Okay, on the other hand, I told you before, there's ways of putting the now back in. When it comes to this subject, there's a poem I like. Let's see if I can remember it right exactly. It's by a minor poet. I can't remember his name exactly, but it has this line: "Is you say time goes, alas, it doesn't go. It stays. We go." Now that seems better to me. I don't have the poem exactly right, but it's something like that. It's more poetic than I said. Okay, so in other words, I think Einstein's eternalist theory is a view in which you can think about, well, an object like me, I came into existence. I'm not sure at what point, that it was me. I don't know when I was. I don't know if became a person when I was conceived or when I was 2 years old or just yesterday. I'm not really sure. But anyway, I think I've been around for a while, and I hope I'm around a little bit longer. Okay, okay, okay. But I think that there was things that went on before I existed and things that will go on after I exist. And if I look at this all if you imagine it from, so to speak, some of these people call it God's eye point of view, but don't take that seriously. There's space time, and there are things that have particular world lines in space time where they came into existence, they go out of existence. Okay. Now I think that you can have that view about what there really is and be an eternalist and still make sense of this kind of metaphorical talk that you were using before. Okay. Or you can be really serious about your metaphorical talk and say, no, no, all that really exists is what's going on now, right around me. And things, different places, they don't even exist, or you might think there is an instantaneous now everywhere. So you can do different versions of this. And there are ways of developing that view such that you could still fit relativity in and say everything about it. And so, it's very awkward. So I think being a presentist is one of these ad hocery things. Uh, it might make you feel good because the language that you ordinarily use seems to fit better, but it just makes you feel good. It shouldn't really make you feel any better.
So, aside from that specific example, though, do you think there are cases, potentially, where someone can have legitimate philosophical grounds for rejecting a certain scientific theory, or at least one interpretation of a theory in preference for another? Can you have philosophical warrant for your proposed rejection of a scientific
Well, there
theory or
have
an
been philosophers
interpretation
who've
there?
done that. I mean, they're philosophers who are, skeptics, think they've given philosophical arguments that we're brains in vats, or everything is like in the Matrix or something like that. I mean, I think these are really bad and not persuasive to me. It's not like I can refute any of them literally because these arguments are made up in such a way that they're somehow not refutable. Okay, but but I don't go for them. Um, so I I don't really know myself of any what I think is what you call legitimate philosophical arguments that would lead to rejecting a philosophical theory exactly, unless, well, maybe I can. I mean, the way you framed it. So consider, for example, we were talking about quantum mechanics earlier. I didn't go into detail about the Copenhagen interpretation of quantum mechanics. But the Copenhagen interpretation of quantum mechanics says that, look, if you're going to describe the world to get the correct results to experiments, there's a wave function, and the wave function says what there is at any time. And if you make a measurement, the wave function will make a prediction, depending on what you measure, about what the probabilities are of various results to the measurement. And now, what happens to the wave function when you make that measurement? Well, the wave function instantaneously changes, become a different wave function. The wave function which now says that you've got a definite value for the thing that you measured. Now, I think this is really bad theory. It's one reason I'd say this is a philosophical reason is that it hasn't said what a measurement is. Until you have a account of what counts as a measurement, you don't have a definite theory. So a philosophical argument would be, look, a good scientific theory has to be definite. It has to say when the fundamental ontology, the wave function, changes from being one wave function to the wave function you get when the measurement is made by saying what a measurement is. So I think that's a philosophical argument. Or here's another one in quantum mechanics you probably have heard of. So one of the ways of getting rid of this changing of the wave function is to say that the wave function doesn't change when people make measurements, but it really does describe many worlds all at the same time. So-called many worlds interpretation of quantum mechanics. Okay. Popular around Oxford, actually, so you may have heard about it at Oxford. Okay. Okay. Now, I don't know if you want to go into it. I can describe the theory more of why anybody would hold it. But what the theory is literally saying, here's what's really, really in reality, is this wave function, and it's describing what there is. And what it says is there's you making a measurement in a world. When you make a measurement, you have successors, which see different values in the measurement. So you're now constantly becoming different yous. You're constantly splitting, becoming more and more. I mean, this might make you very excited. In fact, on this view, understood in a certain way, you'll never die. Okay, because there'll always be a certain probability of you continuing to exist. So you might say, "Oh, isn't that great?" On the other hand, on this view, also, you'll have successes which are dying all the time. So I don't know how happy it should make you. Okay, but in any case, there's a philosophical argument against this kind of view, which I find convincing. And that is, if you look at this view and you say, what does probability really mean when you say that deterministically everything is happening? Because quantum mechanics makes probabilistic predictions. How are you to understand them? Now, I'm not saying there aren't answers, because this is something that's been discussed in detail in the philosophical literature. I've written about it, and a friend of mine has written about it in detail, and I've written responses to responses back and forth. But there's a philosophical argument that this theory not going to work out because it can't make sense of probability. Now, I guess at this moment I believe that's right. So I think there's a philosophical argument to reject this particular scientific theory or interpretation of quantum mechanics. But I might be wrong, okay, about it. So I don't think anything is conclusive here. Okay. On the other hand, I don't think there are good theological arguments to reject scientific theories. Okay. So if somebody says, look, it says in my religion book that the earth was created, you know, uh, um, 6,000 years ago, that conflicts with scientific theories. I'd say screw that. Okay, that's no reason to believe that. In fact, I don't think that's said in any religion book anyway. There were certain theologians who believed it at a certain time. Okay, but nobody takes that seriously now. Now, what's happened? This is something that I'm not an expert on, so I shouldn't go off on it. But how uh, theology has it, which was in the business of saying what there really exists in the world in the Middle Ages, it of course has had to absorb the fact that this other subject, science, when other enterprise science went around saying what there really is in the world, and it disagreed with what theology said, and science was ended up producing airplanes and cars and TV sets and computers and stuff like that, and religion ends up producing wars. Well, other good things too, but so it's and I think many people who take religion seriously have said, we should not think that religion is in the business of saying what there really is in a way that conflicts with science. Maybe it's right to say, where I was saying before, scientists kind of have faith, maybe somebody might look and say that a way of understanding that faith is by positing something that sounds more religious. I don't, unless you want to pursue that, I'm not going to go any further with that idea. But but I do think, connected to what you said, I don't think there are philosophical arguments that are going to undermine scientific theories in the same way that theological arguments really just get kicked out by scientific theories.
Well, that's very helpful. In my efforts to develop a signature touch and uniqueness for the channel, I'm testing out different ways of ending the podcast in a unique way. But what is one event or memory that has significantly shaped your philosophy and thinking above the rest? Like, what's one event or memory that sticks out to you as very formative in your philosophy and in your thinking? So it's a more personal question.
Well, I'm not sure I could say one event. A number of things come to my mind. I had many important and great teachers and colleagues. And I told you earlier, when I got into philosophy, I hadn't taken a philosophy course as undergraduate until I asked this physics teacher about the nature of probability. And I went to a college in Massachusetts called Amherst, little college there. It was a very good college. And there was a philosopher of science there. And, he didn't publish very much, so I'm sure you don't know of him, named Joseph Epstein, but he was quite good. And I talked to him about it, and he got me interested in philosophy just by talking to him about the nature of probability. So I would say that hearing the lectures by John Bell, I don't know how they shaped my philosophy so much. I was already, an established philosopher when I heard Bell give these lectures, but I was certainly incredibly impressed by him. I have a friend. I'm not sure if you want to interview him or not. He's not necessarily somebody who likes to be interviewed, but he's my best friend named David Albert. You know that name?
Mm, mm. I
Okay.
would love to talk to him.
Okay. So I don't tell him that I suggested him
That
because
you said that you said you'd love to,
if
David. I would. So I think you have to now.
you do that, I'd be very angry.
Fair. I will not.
But I talk to him pretty much every day, and he shaped my philosophical thinking in philosophy of science a lot. Because I would say, for my money, he's the best philosopher of science in the world right now. And he actually does not have a philosophy PhD. And to tell you the truth, I will leave you with this. Okay, I'm not sure I should really say this in public, but my main contribution to philosophy, I think, was convincing him to change. He was a physicist, to change from being a physicist to being a philosopher. But you should look at his writing. He's made very superb contributions. And we didn't really talk about the project that he and I are working on, which is what I thought we were going to talk about. But that's this thing called the Metaculus. But save that for another. It's fun talking to you, and as you can tell, I like to talk. So what happens when you get? I didn't realize I was getting old until fairly recently. I used to think I was still like 25 years old. Now I have two children, one of whom is about 50, and the other one is in his mid 20s. And so that one who's in his 50s has a kid who's, like I was saying, I have grandchildren from him. And so I know that in getting old, but one of the things that happens when you get old is you sit around, you like to talk about your life, okay? Because but that's weird. And some people find that very unpleasant, but you seem to not mind it because you're doing podcasts. Doing podcasts is a very good way to learn philosophy. That's what this guy at Stanford he's a very, very good questioner in making asking sharp, incisive questions. I think your questions are very good too. I probably talk too much actually in our podcast, but um, uh, he told me that he decided this is the way he'd learned philosophy, and he was very smart to do it like that.
I have. I wouldn't go that far to say this is now my way. I would say I have discovered an additional way to do philosophy, which is through this kind of medium. I'm able to speak to the world's leading experts in both science and philosophy, as long as they agree to an interview, if they respond to my email. And then I suddenly have an hour to 2 hours to just ask them my questions. And it's just phenomenal. I mean, talk about an education. So even if nobody listens to this podcast, it will have been worthwhile because I'll have benefited so much.
Maybe I'm sure I won't listen to it because I hate the sound of my voice. But maybe I like. Oh,
Everybody
my
does.
wife,
Everyone hates their
incidentally,
own books.
my wife is a philosopher, and she's doing interesting
Mm.
stuff. I'm not sure she wants to be interviewed, but I will tell her. She's very interested in what AI is going to do to the world, and that's a very interesting
I would
question.
love to speak to her.
Her name is Katalin Balog. She writes
Okay.
semi-popular. She's a philosopher of mind who writes about consciousness. She's been interested in
Okay.
about consciousness, but she's interested in this subject. Okay, are we done with our interview part? I wanted to ask you one or two questions because I got to know you
Yeah.
a
So
little bit.
I'll say goodbye in the recording, and then you can ask me the questions.
Okay, goodbye. That was fun. Thank you. Okay.
Of course. Thank you so much for coming on.